Hi everyone! In this video, I'm going to show you guys how to write the proof for this statement right here. So the statement says, the negative of any odd integer is odd. So the first thing you want to do when you're writing a direct proof is you want to turn this sentence into an if-then statement. So here we're dealing with one variable because it just says any odd integer. So you could say if m is an odd integer, then the negative of m is odd. So the negative of m is odd. Now we can start writing our proof. So the first sentence you want to write is suppose, and then the if part of the if-then statement. So suppose m is an odd integer. So now we have to address the technical words. We don't have to define what an integer is, but you do want to define what odd means. So I have the definition right here. It means a number is odd when there exists an integer k such that the number equals 2k plus 1. So by definition of odd, m equals 2k plus 1, where k is an integer. Or here it says k is an element of the set of integers. So now we can introduce negative m. So then negative m equals negative of 2k plus 1, which equals negative 2k minus 1, which equals 2 times negative k minus 1. So somehow negative m will have to be in the format of 2 times some integer plus 1. So what does this equal? Well, it could equal 2 times negative k minus 2 plus 1. Because negative 2 plus 1 is negative 1. So now, if we factor out a 2, we could say negative k minus 1 plus 1. So if you distribute this, it equals 2 times negative k, which is 2 times negative k, minus 2, plus 1, plus 1. So now we have 2 times some integer plus 1. So negative k minus 1 is an element of the integers, because integers are closed under multiplication and subtraction. Meaning if you subtract integers together, the difference is an integer. If you multiply integers together, the product is an integer. So now you could say let r equal negative k minus 1. This means negative m equals 2r plus 1, where r is an element of the set of integers, which is the definition of odd, which we defined up here. Because an odd number is 2 times some integer plus 1, and that's what this is. Thus, negative m, and then we write the then part of the if-then sentence. Thus, negative m is odd. And then we could write a little square right here to indicate that this proof is done.